Welcome back to the Start to Finish course on upgrading to .NET Core. We are currently in the module focused on adding some of the common .NET Core features into our application. And this lesson, we're going to be focusing on dependency injection. So this comes baked right into .NET Core projects. You can upgrade it if you want, but the base dependency injection is pretty good, and it should cover the majority of your needs. So let's look at how to do that in our project. Now, like I said earlier, the MVC project is actually technically a brand new project. And so we have all of the setup and the dependency injection, all that other goodness built right into how our application works. We don't really have to touch it in order to get it configured. And this section, this module is going to be focused on configuring and getting it set up, not using it necessarily yet. We're going to work on using some of these things going forward in another module once we have configured everything, got everything up to speed. So the MVC project is up to speed. It's got dependency injection, it's got logging built in, it even uses the app settings.json, even though we also have our app.config. So that's pretty much set. Let's close all these. And let's look at what we have in our WinForm project. In program.cs, it just says, go ahead and start your application. There is no logging, there is no dependency injection, and we don't have an app settings.config. And if you were to say, well, we should start a brand new WinForms project and use those settings and bring them over here, the problem is that they aren't configured. And that's something I think is going to come down the road with .NET Core, is they'll configure .NET Core in a similar manner in WinForms and WPF. But for right now, there is no configuration. There is no setup for these things. So we have to kind of extract and create our own setup in order to get this to work. Now I do want to use, for dependency injection, I want to use the base built-in .NET Core dependency injection. I could have just added autofac in here and ignored how this, the built-in stuff worked. But what I want to do is I want to make it as close as possible so that when I use dependency injection in my tracker library, that it works the same way in the MVC project as it does in the WinForms or WPF projects. So I'm going to try and keep things as similar or the same as possible. I guess as similar as possible and not the same as possible. Okay, so let's start by adding a couple of NuGet packages to our tracker UI. We're going to start with Microsoft.extensions. And let's see what the list shows us. There's a bunch of different extensions here. One's for logging. We're going to add that one later. But what we're looking for is for dependency injection. There it is. Oh, that's for abstractions. Let's just type it all out. There we go. Dependency injection. So Microsoft.extensions.dependency injection. Install that. And the one more we want to add is for hosting. Microsoft.extensions.hosting. And it's actually way down the list here, which is confusing because I would think it'd be at the top, especially above the Microsoft.own.hosting, which is something different. So Microsoft.extensions.hosting, install that as well. And that should set us up to start working over here in our program.cs. Now, if we look in the MVC project at program.cs, we have this method here, create host builder. We're going to do something similar in our project, but it's not going to web host default. So let's come over here. We're going to create a new method, public static iHost builder. We're going to control Now, what we can do here is we can actually accept args into our static void main. So string array of args. If you didn't want to accept arguments into your main, which these arguments will be like command line arguments. If you don't want to accept those, you could just say new string array here instead and just pass no arguments essentially. So this is going to build and set up our dependency injection system. But right here, we're already violating dependency injection by saying new tournament dashboard form. So let's do this. Let's add to our services, services.addTransient. We're going to do a control dot here to add the using statement for Microsoft.extensions.dependency injection. So add transient. We're going to add transient for tournament dashboard form. Like so. We don't have an interface for it, and that's okay. We can just use the actual type. By doing this, what we can do here is instead of instantiating our new tournament dashboard form, we can say host, which that's this variable up here, host dot services dot get service. And you want a tournament dashboard form. Okay, that's the equivalent now of asking the container to give you a new instance of tournament dashboard form. Let's set this as a startup project and run it. Okay, build succeeded, that's good. We've made that step at least. And it started right up. So we have now implemented dependency injection. They may say, well, how do you know it's actually working? Well, because this right here just asked for that from the service. But I get it, because it may be that that's kind of fooling it, or maybe it doesn't work everywhere, or whatever you want to say. No problem. Let's go to our tournament dashboard form code behind, and let's just ask for a class. Let's say we need a create tournament form. So I'm going to say create tournament form, create tournament form. Let's call it the whole name. I'm going to ask for this form right here. And then instead of asking for it down here, well, no, you know what? We're not going to go that far. We're not going to modify our application. I don't want to go that far. But what I'm going to do is we're just going to prove that this form does come through. So I'm going to put a breakpoint right here so you can see that it is an instance of this tournament form. I do need to add this to our dependency injection system. So services.addTransient. And that's all I have to do. Now, when I run this, it should hit that breakpoint. We should see a new instance of that form. So create tournament did work. And if you notice create tournament, it is an instance of that form. It's got all the goodness of that form inside of it. So we are working, we are injecting. Notice we put a constructor on this form that is taking in something that only the dependency injection system is able to inject into it. So we are working the way we were expecting it to. So now let's get rid of this. I'm even going to get rid of that form, even though we're going to put it back. I don't want to have a mess of half-done things. So just enough to get to working, we now have dependency injection running in our WinForm project. Now, as .NET Core progresses, I think we'll see a couple of tweaks here. And so I'm developing this course before .NET Core is officially out. The preview version is out. The general availability version is ready. We have the code for it. So the one thing that's going to be different, I think, is even if they don't provide all of this, normally you have a .run here. But what that .run does is it runs the application and blocks the calling thread until the host shuts down. Well, the problem with that is that it would not allow any of this to happen. Normally what happens is down here in configuration, you would pass in, okay, when I say run, here's what you run. And you'd pass in, let's say, tournament dashboard form. We don't have that yet for WinForms. That's something that's coming. So until that point, this is how we do it. We don't add the run at the end here, and we're all set. So like I said, WinForms is now done and working with dependency injection. Let's move on to WPF. We don't need to worry about the tracker library because the tracker library isn't a UI. And so we don't have to do anything in the tracker library, just the user interfaces. So let's go to our WPF project, which doesn't have a startup. There isn't a place that says start this code. What we do have, because of this project here, is we have Bootstrapper. And that's where we kind of initialize our project and set the root display for and all the rest. So this is a little bit different because it's Caliburn Micro. Caliburn Micro has the concept of Bootstrapper. It deals with connecting up our classes and our instances. And so just trying to plunk in the default dependency injection system from .NET Core won't be the best solution. So we need a different solution for how to get this to work for Caliburn Micro. And that'll be using Simple Container. Now, I don't want to go too far here though, because I want to show you Simple Container. We'll do that. But at the same time, if you're not using Caliburn Micro in WPF, you still want to add in the default dependency injection from .NET Core. So what I'm going to do is I'm actually going to create a sample WPF project for you to show you that as well. I just want to make sure you have the full picture here and aren't missing a piece because you're not using Caliburn Micro. So let's right-click on the solution and we're going to add a new project. And this project will be standalone. It's not going to use our DLL. It's not going to do anything. It's just here to kind of show off, here's how you do things. So let's go with a desktop application in C#. WPF app.NET Core is what you want. We're going to hit next. And we're going to call this simple WPF demo. We'll hit create. And this should have the very, very standard main window. And that's it. Okay, so let's go ahead and add dependency injection here. Where I'm going to start with this is in the app.xaml. There's a code behind for that is empty. I'm going to create a class here, or I'm sorry, a method in our class, public static iHost builder. Now control dot, I don't have that yet because I need to add those NuGet packages. So Microsoft.extensions.hosting, that's right here, and Microsoft.extensions.dependency injection. That's the second one right there. We'll install those. And now if we do a control dot here, we can add that using statement in. And we want to say create host builder. And again, take in our args like so. And we're going to return host.create default builder, taking in our args. And then doing our dot configure services. And we'll two sets of parens here, host context and services. And that's a lambda expression, like so. And we're going to add services.add transient. And control dot there to add our using statement. And we're going to say main window. Just like what we did in the WinForm project. Pretty much identical for that to get that working. Okay, so now I'm going to create another method, public void app underscore on startup. Object sender and startup event args e. This is a event handler. So in here, what we're going to do is say var host equals create host builder. We're going to pass in our args. We don't have any args. I'm just going to say new string array that's empty. That's it. And dot build. And then I'm going to say host dot services dot get service. And that service is going to be main window. And I want to show dialog. And the reason show dialog is because show dialog will open the window and return only when the newly opened window is closed. So it's going to wait to close out this app on startup until after we close our main window, when we're exiting our application. What that will allow us to do is later when we add logging in, we can say flush the logs after this happened, basically close things down properly. So with that, we should be able to set the simple WPF demo as a startup project and run this. And there's not much to this. It's just a window. It's going to pop up. It's going to be empty. Woohoo. Not much there. But we just implemented dependency injection for WPF. Let's just prove that by adding a simple class. Let's call this class the do work class. Never name your class do work. And we're going to have a public void work method that just does a console write line that says I am working. Okay, so now in our dependency injection system, we can say services.add. Let's before we do this, let's actually create an interface for that. There's not really a need for it, but at the same time, just to prove that it could do it. And if I run this, just by asking for it, it blows up. It doesn't work. And so the question is, why doesn't it work? And it says, no default constructor found for type main window. Well, yeah, because I'm using the dependency injection system. Well, no, you're not. And that's one of those things to catch, is that in app.xaml, we have a startup URI that says main window.xaml. This is where it's helpful to know how these things work. In this case, how does it know to start up main window as the window that it starts with? If it was a brand new application, main window is the one that launches. How does it launch? How do we know that it launches? What's kicking it off? Well, this is what's kicking off, app.xaml. So I want to change that. I want to change this to say, don't start up app.xaml. Instead, I want you to call this app underscore on startup. Well, I could paste that in there, but it's not going to work because it's a startup URI. Instead, I need to startup. Now, if I save this and run it, wait for it. Okay, we hit our breakpoint. And we can see that worker, in fact, does have an instance in there. And if we were to step over this, then our output somewhere in here, I believe, should have the that I am working. So we now have a working dependency injection system for WPF. So that's really it takes some tweaking, but once you get it to work, there's not much to it. It's just really this little bit of code inside of app.xaml.cs and that one tweak on the app XAML itself. Get those two things in place and you have dependency injection in your WPF project. Now, that's what we do if we don't have Caliburn Micro installed. But what if we have Caliburn Micro installed and we have this bootstrapper? Because notice in app XAML, we call this bootstrapper here, and that's how we launch our application. And it does some Caliburn Micro-y stuff. Well, Caliburn Micro is different, so let's wire it up in the way that Caliburn Micro prefers. The nice thing is that even though we are doing a different dependency injection system, that's kind of the beauty of dependency injection. The only place that we have to worry about the differences is in the configuration itself. So how we configure this will be different than how we configure our bootstrapper, but everything else will be the same. We can use the same class library that uses dependency injection systems. We can use that with either dependency injection system because it's the same structure. We're going to pass in things through the constructors. So let's configure this. We're going to start by saying private simple container. Let's call this container equals new simple container. We're actually going to new something up. It's just a container itself. That's the dependency injection system. We do need to add a few overrides. So protected override. This is going to override the get instance, a singular get instance. And instead of doing the base, we're going to say underscore container dot get instance and service and key. Okay, so what we're going to do is we're overriding something that's built into Caliburn Micro and saying, well, we're not going to use your kind of behind the scenes way of getting instances. Instead, we're going to use the simple container, which is their built-in dependency injection system. And so whenever you ask for an instance, here's how you get it. Call the container and ask for an instance. We need to override another one. So protected override, and this is the get all instances. And so instead of calling the base here, we're going to say container dot get all instances of service. Okay, so it's passing the type that's passing in. We're saying get all instances of that. And finally, we have the build up event. So protected override the build up. And in here, what we're going to do is say container dot build up and pass in our instance. And that instance is whatever's being passed in. Now this all comes right from the documentation in Caliburn Micro's site. Pretty simple stuff to just almost copy and paste. That's pretty close to how it is. So it may not be totally simple as far as understanding it. I understand that, but their documentation is pretty great. So I'm actually going to, let me put the URL, let's put it up here. There you go. So there's the documentation for the simple container inside of Caliburn Micro. I don't remember all these things off the top of my head. I use documentation or my previously built projects to help me out. So now what we need to do is we need to add in our configure method. So let's do that near the top. And that is protected override configure. And this will allow us to configure our application. So for example, if we want to add an instance of something, we can do so. One property here that says this works. That's it. Okay, so it's a weird little class that has no purpose, but I'm going to add that on a per request basis as well. Just to demo, I capitalize F, info. Whatever, we're going to leave it. Why not? It's quirky. So now in our view model for the shell view model, we're going to ask for demo info. Just to ask for it. And just make sure that our dependency injection system is working properly. Let's set this as a startup project. And let's run this. And we hit our breakpoint. And demo has that this works property. Of course, it's null, but that's okay. So our dependency injection system is working properly. It's always good to test those things and make sure that your assumptions are right. Otherwise, the previous WPF project we might have thought was working properly when in fact it wasn't. Okay, back over here, let's delete the demo info. Sorry, it's going away. And we're going to take it out here too. And now we have dependency injection working in our Caliburn Micro project. Now we're using Simple Container, which is a different dependency injection system than the built-in .NET Core dependency injection system. And that's okay. Because again, dependency injection works based upon the configuration and it doesn't really care about it in the implementation. If your class library has to use one specific type of dependency injection system, you're probably using it wrong or using the wrong dependency injection system. It really shouldn't care about which dependency injection system you're using, just that it works. And that's what we're going to do here. To .NET Core, and that's logging using the iLogger. So we'll get to that next.